In this video, we're going to look at the Unit 1B review for the test in pre-calculus. This video is going to cover piecewise functions, transformations of functions, and compositions of functions. Number 1 gives us two different graphs of piecewise functions, and it asks us to write the equations of the functions and then also give the domain and range. So in part A, we can kind of see that there's three different chunks to this graph. And so I'm going to just start out the function by getting this written. So we're going to write a piecewise function like this. It's going to have three different parts. And I'm going to color the graph in different colors for what I write the function in. So this side of it, and I'm going to do this as an open circle. Now these overlap, so you're just going to have one of them as an open circle and one as a closed circle. So for this one, our domain starts at -1 and its numbers lower than -1. So this is going to be x's that are less than -1. I'm not going to do an equal sign because, again, I decided to have this as an open circle. So now we want to write the equation of this line. So it's going to be in slope-intercept form. And so if you take a look here, we've got this point here is at 5, and then we're going to go down to 3 and over 1. Okay, so this is at 5, 4, 3. So this is down 2 over 1 for the slope. So the slope of this line is -2. So that's going to be -2x. And now I want to figure out where it crosses the y-axis. So I'm going to continue this down 2 over 1. If this continued, it would cross the y-axis at a +1. So the equation for that graph is -2x plus 1. And that happens for domain values of x is less than -1. I'm just going to make this a little bit smaller here so I can fit the rest of this. Then this middle part of the graph is just a constant. And so I'm going to have this as a closed circle here, and I'm going to have it as a closed circle here. So this line is at a y value of 3, and it stays constant, meaning there's not going to be a variable. So this just stays 3 the whole time. And the domain here, it is at 3 between the x values of 1 and 2. Sorry, -1 and 2. So -1 is less than or equal to x is less than or equal to 2. And again, I chose to do closed circles on this middle part here. Then the final part of this graph is this line. So again, we're going to need the domain starts at 2, and I'm doing this as an open circle. So the domain is going to be 2 and higher. So we want x's that are greater than 2. And then this is a line. So we need to figure out the slope here. And so if we look at this one goes up 2 over 1. So the slope of this one is 2. So that's going to be 2x. And then we want to figure out what the y-intercept would be. So if I continued that pattern and I went down 2 over 1 and then down 2 over 1 would put me here. So this was at 1. So down 2 more would be at -1. So this is an equation of 2x minus 1 for this one when x's are greater than 2. Then the domain here, we can plug in all real numbers because this goes from left to right. Everything can get plugged in. So the domain here is -infinity to infinity. And you can see that left to right, everything is there with those arrows. Then the range gets stuck here and goes higher. So the y values start at a y value of 3 and they go to infinity. Part B is similar. We've got 3 different chunks here, so I'll just get the equation part set up. And I'll use color to kind of show you where we're at here. So this one is a quadratic. So this portion of the graph, if I do the domain part first, is at -1 and lower. And I'll just do this one as an open circle. So this is x's that are less than -1. And then this one is a quadratic. So I'm going to use transformations from the parent function to help me with this. So we can see that the vertex is moved over here to the left 3 units. So that's going to be a +3 inside of this quadratic. And then it's moved up 4. So we're going to have a +4 on the outside. It's also flipped vertically. So it's going to have a negative out front of that. So that would be the equation for that parabola if our x's are less than -1. Then this middle portion is here. And I'm just going to do, again, I'm just going to choose to do closed circles on this middle portion. And so the x values here that are represented are from -1 to 3. So we have -1 is less than or equal to x is less than or equal to 3. This one's a straight line. So then we need to count the slope again here. So you can count the slope kind of anywhere in here that you want to. So I'll go from this point up to over 1. So the slope here is 2. So 2x. And then it crosses the y-axis at 2. So the equation for that is 2x plus 2 if we have x's that are between -1 and 3. Then the final portion of this graph is just a constant flat line at y equals 8. And that is for x's that are greater than 3. So again, I'm just doing an open circle here. And so it's 8 if our x's are greater than 3. Then the domain we see goes all the way left to right because we see this arrow here going to the left and this one going to the right. So -infinity to infinity. And then our range has an arrow going down and then it goes up until 8. So it gets stuck at 8. There's nothing higher than this 8. So the range here is going to be -infinity up until 8, and 8 is included, so we'll have a hard bracket there. Number 2 asks us to graph a piecewise function. So now we have these 2 different parts of our piecewise function. So I like to take a look at the domain and create a table of values. So in this case, I'm going to have a table of values where x is greater than -1. So I want to do numbers that are -1 and higher. So I'm going to do -1, 0, 1, 2, and if I need more, I'll plug those in because I'm going to do as many fit on this graph. And the function I'm plugging into is x squared minus 3 for this one. So then we'll do -1 squared, which is 1, and 1 minus 3 is -2. 0 squared is 0, minus 3 is -3. 1 squared is 1, minus 3 is -2. 2 squared is 4. 4 minus 3 is 1. So I'm going to plug in 3 as well, see what that gives me. So 3 squared is 9. 9 minus 3 is 6. So that's going to be off my graph because my graph goes up to 5. So let's start plotting this. Now at -1, it just says greater than. So this is going to have an open circle. At -1, -2, we'll have an open circle. Then we have a point at 0, -3, at 1, -2, at 2, 1, and at 3, 6, which again goes off the paper, but going to be somewhere like that. And then you can just connect those. Then we'll plug into the next part, and I'm just going to make this smaller so that we have room to fit the other one. So now we're going to look at this domain, -4 to -1. So those are the only values that we're going to plug in. So we're going to plug in -4, -3, -2, and -1. Those are the only ones in that interval. And we're plugging these into 2x plus 1. So -4 times 2 is -8, plus 1 is -7. -3 times 2 is -6, and then plus 1 gives us -5. -2 times 2 is -4, plus 1 is -3. -1 times 2 is -2, plus 1 is -1. At -4, we have an open circle. So this one's going to be open, and then this other end is going to be closed since it has the equal sign. And then we'll just plot those points. So -4, -7. Now this is going to go off my graph. So I'm just going to go, that's at -6, and this is -7 down here with an open circle. -3 is at -5. -2 is at -3. And then -1 is at -1. And then that's a closed circle. And then we can just connect those. So now it asks what's the domain of this function. And so we can plug in numbers from -4 on, because this continues to go. And we actually don't get a value at -4. So -4 is not included in our domain, but everything above it would be included. So we'll have a soft bracket there. So -4 to infinity. And then this asks if our function is continuous. So that means that there's not going to be any breaks. And there is a break here. So there's a jump discontinuity. So no, because there's jump discontinuity at x equals -1. Number 3 asks us to transform f of x the way that it asks here. So here's our function, okay? And now we're going to be doing these different things to it. So this f of x minus 2 plus 3, the minus 2 is going to move us to the right 2 units, and the plus 3 is going to move us up 3 units. So each of these points, we need to do that. So if we take a look at this point, it's at 6, 0. So if I go to 6, 0, now I'm going to go over 2 and up 3. And that'll be my new point. This point is at 3, 5. So if I go to 3, 5 on this graph, I'm going to go over 2 and up 3. This point is at -1, 5. So if I go to -1, 5, I'm going to go over 2, up 3. This point is at -5, 1. So if I go to -5, 1, we're going to move over 2 and up 3. And then this last point is at -7, 5. So if I go to -7, 5, we're going to go over 2 and up 3. And then you could just connect those. I'm going to use this segment maker here. So here's that graph moved to the right 2 and up 3. Now this next one is going to take the height and multiply it by -2. So this is a vertical stretch by -2. So we're going to want to take the height and stretch that first. Then we're going to want to move it up 4. So that -2 is going to multiply the height by -2. So that's going to flip it and stretch it at the same time if we multiply by -2. So when we go over here, this one has a height of 0, right? So from the x-axis. So 0 times -2 is 0. And then we'll move up 4. So this 6, 0 is just going to end up moving up 4. This next one here, okay, at 3, 5 is now going to multiply 1, 2, 3, 4, 5. So that's going to multiply 5 by 2 and really by -2. So this height is now going to become -10. and then we're going to move it up 4. So I'm going to go to the same x value. So I'm going to go to 3, negative 10, and then I'm going to go 1, 2, 3, 4 up. So multiply by that negative 2 and then move it up 4 on the same x value. So this next one is at negative 1, 5. So again, this height is 5. It's now going to be negative 10. So at negative 1, I'm going to be at negative 10. And then I'm going to move up 1, 2, 3, 4 units. This point is at negative 5, 1. So this height, 1 times negative 2 is negative 2. So now we're going to be at negative 5, negative 2, and then we're going to move up 1, 2, 3, 4 units. And this last one here is at negative 7, 5. So again, we're going to multiply this by negative 2. So the height is going to be negative 10. So we're going to go over to negative 7, and that height is going to be negative 10. And then we're going to move it up 1, 2, 3, 4 units. So there's those points, and then we would just connect them. So this shape has been flipped over the x-axis and stretched by 2, and then moved up 4. For problems 4 through 9, we're going to use these different functions here to perform these operations, and then we're going to simplify them. So in number 4, it asks us to do g of x minus k of x. So I'm going to use purple for the g function here. So g of x, and then we're going to subtract k of x. So I'll use green for the k function. So we're going to subtract k of x here. So when you plug this in, be really careful with subtraction. So this is x squared minus 4. And then we're subtracting this whole k function. So make sure you get it in parentheses. And so k is 5 minus 2x. So you'll want to distribute that negative. So we have x squared minus 4, and then we have minus 5 and plus 2x. Then you can combine your like terms. So we have x squared, we have a plus 2x, and then negative 4 and negative 5 is negative 9. Number 5, we're going to do h of x. So h of x divided by g of x. So our h function will go on top, and the h function is just the square root of 16 minus 3x. And then the g function is just x squared minus 4. There isn't anything that we can do to simplify that, so this would just be our final answer. Number 6 asks us to do a composition. So we're going to do g of h of x. So we're going to plug the h of x function into the g function. And so the h of x function is that square root of 16 minus 3x. So we'll put that into the g function everywhere we see x. So the g function is something squared minus 4. And that's something that we're squaring in this case is the 16 minus 3x. Now for this one, we have the square root over the whole inside and then squared. So the square root and this squared will cancel. So we get 16 minus 3x minus 4. We can combine our like terms. So 16 minus 4 is 12, and then we still have that minus 3x, and that would be our final answer there. Number 7 asks us to do h of 2. So that means we're going to plug 2 into the h function. So the h function is the square root of 16 minus 3 times x, which in this case is 2. So we have 16 minus 6 under the square root, and that gives us the square root of 10 as our final answer. This next one has us do g of 3 on top, and then it has us do f of 3 on bottom. Now, I would calculate these separately and then divide them. So the g function, so if we do g of 3, so g is 3 squared minus 4. And so that is 9 minus 4, which is 5. So that's going to be on the top of our function. I'm just going to let that sit there for a second. So then if we do f of 3, now f is a bit more complicated because it's got a fraction there. So we're doing 3 times 3 on top minus 1. And on bottom, we're doing 2 times 3 plus 4. So this would be 9 minus 1 on top, which would be 8. And 2 times 3 is 6, plus 4 gives us 10 for the bottom there. So this would then simplify to 4/5. So that's the bottom of our fraction here. So the top, g of 3, was 5. And then the bottom is f of 3, which is 4/5. So when we go to simplify this, remember this is just division, and dividing is the same as multiplying by the reciprocal. So we'll flip this. So it's the same as multiplying by 5/4. And then for multiplication, we just multiply the tops together. So 5 times 5 is 25. And then the bottoms is 4. So then that would be your final answer. Then number 9 has us plug g of 0 into k. So let's figure out what g of 0 is first. So we plug 0 into the g function. So we'd have 0 squared minus 4. So 0 minus 4 is just negative 4. And then we're going to plug that into the k function. So we're doing k of the negative 4. And our k function is 5 minus 2 times that negative 4. So then we end up with 5 plus 8. So we get 13 for that one. For questions 10 through 13, we're going to use the graph to help us with these different function operations. So this first graph is the graph of f, and this second graph is the graph of g. So this first one just asks us to do f of 3 plus g of 3. So we're going to go over to the f function, and we're going to plug in 3, which means look to the x value of 3. What y value do we get back? So f of 3 is negative 2. Then we're going to look to the g function of 3. So we're going to go to 3 on the g function and see what the output is. So at 3, the output is 1. So we're going to do negative 2 plus 1, which gives us negative 1. This next one, we're going to subtract the two functions. And this time we're plugging in negative 1. So we'll go to the f function at negative 1, gives us an output of 1. And then the g function at negative 1. So here's negative 1. The output is also negative 1. And so if we do 1 minus -1, we get 2. This next one is going to have us do a composition of the functions. So we're doing g of f of -2. So first we want to plug in -2 to the f function. So we'll go to -2, and that output is 0. So f of -2 is 0. So then we'll go to the g function and plug in 0. And the g function at 0 is also 0. So the answer to this number 12 would just be 0. For 13, we're going to plug, we're going to plug the g of 1 into f. So we're doing f of g of 0. Oh, sorry, not 0, 1. So we'll go to g of 1. So here's 1 on the g function. It gives us back 1. So g of 1 is 1. So then we'll go to the f function and plug in 1. And that gives us back 2. Then for number 14, it asks us various questions about these graphs. So, and we're just supposed to do the x values or the intervals where these things happen. So for part A, it says, when does f of x equal g of x? And so we can see that happen here where the two functions intersect, and that happens at x equals 10. Then when does g of x equal 0? And the g function is this one down here. So when does that equal 0? And that happens at -6. It happens at 0. It happens at 2. And then it happens here at like 9.5. Part C asks us, when is that g function above 0? So when is it greater than 0? So it's greater than 0 here, and this is on a whole interval. So it's greater than 0 from 0 to 2. Soft brackets because it's not greater than 0 at 0. It's actually equal to 0. And then here it's also above 0 from 9.5 to 11. And again, not including 9.5, because at 9.5 it's 0, but at 11 it's greater, so that would be included. Then when is g of x less than 0? So that's when it's below the y-axis, or the x-axis, sorry. So these places. So from -6 to 0, again, not including either of those. And then from 2 up to 9.5. And then E is asking us where are the intervals where f of x is greater than g of x. So when is the f function above the g function? And so that's this whole place until 9.5, that intersection where they're the same. So from -6, which it's greater than g there, so that's included, all the way up to 9.5. And at 9.5, it's not greater than, because that's where they're equal. So that would be a soft bracket.